Link is on a spirit train. Its speed increases 25% each second. If Link is currently going 50 miles an hour, how many seconds will it take for him to get to a speed of 1,000 miles an hour? At 15.25 seconds, how fast will he be going? Write a now-next statement for this equation and create a table and a graph. As we can see, we start at 50 miles an hour right here. And the rate of change is 25%. So start equals next equals now times 1.25 because we're adding 125% to every second. So yeah. And y equals 50 times 1.25 because if he's going 50 miles an hour, x would be the number of seconds that you want to times 1.25 by, which is the rate of change. To solve the equation, how many seconds will it take him to get to a speed of 1,000 miles an hour? We can use both the next now equation and the y equals equation. The y equals equation plugged into a calculator will create a graph. The next now equation can form a graph. The start would have to be 50, so 0 equals 50, and then every other number after that would be multiplied by 1.25. To solve at 15.25 seconds, how fast would he be going? We can use the function on the calculator by plugging the y equals equation into y equals and having the calculator make a graph and setting the rate by 0.25, so we can see that he would be going at 1,502.6 miles an hour. Link is riding on the Lernu Desert Rickety Coaster. Its altitude increases at a rate of 7 feet per second and starts at 30 feet. Create a table of values in both recursive and exponential rules. Create a graph from your table. When will Link get to 200 feet, and how many feet would he be after 15.75 seconds have passed? This time, to create our next now equation, we're going to add 7 because he goes 7 feet a second and starts at 30 feet. So start equals 30, next equals now plus 7 would get you this graph. The graph is linear because we're adding 7 each time, so we're not multiplying by any number, which creates a linear graph. To solve the equation, or to solve the problem when will Link get to 200 feet, we can put the y equals equation into a graph and find after 24 seconds he would reach 200 feet. To answer the second part, how many feet will he be at when 15.75 seconds have passed, we can plug it into a table. Then we can find when 15.75 happens, 100, he would be at an altitude of 140.25 feet. Link starts off with 256 rupees. If he spends half the amount of rupees he has each day, how many days will it take for him to have 1 rupee left in his wallet? How many rupees will he have on the 5th day? With both of the previous problems, we can solve it in a next equals now equation or a y equals equation. With the graph, we can see that this is a decreasing exponential rate problem. So in the graph, or in both mediums, we cannot end with 1, or we cannot end with 0 because we can't take anything away from 0. So with the next equals now, when we create our graph, we start when x is 0, so start equals 256, and then we multiply by 1/2, which is the same as dividing by 2. each time until we get down to 1, where we can't divide by 2 or multiply by 1/2 anymore. When we plug y equals 2.256 times 0.5 to the x power, we get this graph when plugged into the calculator. It is a decreasing exponential graph. With the table, we can answer the first question: how long will it take to have him only have 1 rupee left in his wallet, which is 8 days. How many rupees will he have on the 5th day? We can also answer by using the table, which is 8 rupees. There are 100 gold Skulltulas in The Legend of Zelda Ocarina of Time. If Link defeats gold Skulltulas at a constant rate of 4 per day, how many days will have him to earn a piece of heart as a reward for defeating 50 Skulltulas? After 10 days, how many gold Skulltulas at the initial 100 will be left to defeat? So the big thing about this is a constant rate, which indicates that it will be a linear graph and table. So we start at 100 gold Skulltulas, and then we subtract 4 every day, no matter what. In the table, we can see that every day he takes out 4 gold Skulltulas, and so we can use this to solve the equation. After 10 days, how many of the initial 100 will be left to defeat? And so 10 days, there would be 60 gold Skulltulas. To answer the first part of this question, which I did not answer previously, it will take him 12.5 days to defeat 50 Skulltulas. So we can come down, and because they subtract 4, there's 2 to get to 50, so 12.5.